Hi, I'm Nicolas. I'm in charge of DevOps activities at Opinum. Today, I'll describe the different options you have to install Data Hub on your own infrastructure. Hi, everybody. Welcome to this online event. And in this session regarding deploying Data Hub in your own infrastructure, which we also call on-premises mode. So I have divided this session into 5 parts. I will first briefly review some of the main reasons for which you might need on-premises deployment. Then I'll describe the Data Hub main architecture block in terms of infrastructure, so that you have a good overall understanding on how it is deployed. And I'll then switch to the different models we support to deploy on-premises, data center, cloud provider, and so on. And these deployments come with some requirements that you need to fulfill to be able to deploy on your infrastructure. And so we'll review this together as well. That's the 4th section, and I'll finish with a brief explanation about what is currently ongoing at Opinum regarding on-premises deployment and what are the next steps on our roadmap. All right, let's go. So why on-premises? So as a reminder, as you probably certainly know, deploying Data Hub on your own infrastructure, it means deploying it in your own data center, also called private cloud, or in your own cloud provider subscription, for instance, Microsoft Azure. Imagine that you have a subscription in Microsoft Azure. We can deploy Data Hub in that subscription. Actually, most of our customers, they use our shared Data Hub instance, which is hosted in Microsoft Azure and managed by us. And they are very happy with it. However, there are some very valid use cases for which you might need a dedicated instance deployed on premises. And there are some, I will quickly review with you some of the typical reasons for which you might need this kind of dedicated instance. One of them is specific security requirements. Imagine that the security policy in your company requires the data to be hosted in the country of the company. That might be a very valid reason to opt for an on-premises instance. You might say that, right, but for instance, Microsoft Azure might have a data center in your country, which is true. Sometimes it's not, because there is not a data center in each country. However, sometimes the requirement is even stronger, and it requires the data to be hosted in the country in a data center owned by a company of the country, which is, for instance, not the case of Microsoft Azure. Another reason is when you want to leverage an existing infrastructure, whether that's a center that you own or an existing subscription in a cloud provider, which is already configured with a series of enterprise systems, like you have a network, DNS, already Kubernetes clusters, Active Directories, things like that, and you want to leverage and not rebuild everything for the deployment of Data Hub. That's also a typical use case. Another one is when you want to you need to integrate with enterprise, have a close integration with enterprise information systems. For instance, when you have a data collection is happening is made by one of your system, and it needs to push the data to Data Hub, and in some way it will be way more efficient if those two systems are close to each other. That's also a good use case for on-premises deployment. And I'll finish with the fourth one. There are others, but I won't cover all of them. The fourth one is when you have specific performance requirements. Imagine that you have very big volumes or a very big data rate, which are shared instance in the cloud cannot support. That would be a good reason also to go for on-premises. It doesn't mean that our shared instance cannot support big volumes. However, we cannot guarantee very, very big volumes. It depends also of your use case. And most importantly, the resources, the hardware is shared. So we cannot guarantee you that you will have all the resource all the time, because you have to share with other customers. And when you really need to have dedicated performance scaling and so on, it's when you need a dedicated instance of data app. Also, of course, we don't want to impact the performance of other customers if you have very high demand on resources. Okay, next section is about high-level architecture of that app in terms of infrastructure. There are two parts in the infrastructure. We'll have a diagram on the next slide, so that you have a better view on it. But let me first quickly review the two kind of blocks we have. We have blocks which are related to data app, or services and web application, and there are three of them. We have a set of IaaS web apps, as you will see on the diagram. We have a series of Kubernetes microservices web apps, and as well a Redis service that we manage ourselves. And then we have also Service Fabric microservices, which we are currently migrating to Kubernetes, but we still have some of them that we need still to migrate, so we still need to support this. That's it for that app. The other architecture blocks are managed services like database services. I will describe this in more details on the diagram. Enterprise services like DNS, Docker registry, SMTP, and so on, and possibly some external services. So let's go directly to the diagram. This is it. So as you can see here, these are the 2x3 blocks that I was talking about. The three data app blocks: IaaS, Service Fabric, Kubernetes, and then the three other services: external, enterprise, and managed services. So how it works, this is simplified, of course, on this view, but it's enough to give you an idea on how this works. So you have an entry point accessible over internet, so some load balancer, and then you access 4 web applications, actually 3 here and 1 on Kubernetes, which are hosted on IaaS for the 3 of them, and hosted on Kubernetes for the 4th one, which is the main portal, by the way. Our plan is to migrate these web apps to Kubernetes, as we will see on a diagram a few slides later. So I won't elaborate on that right now. Then we have a block which is Service Fabric. This is a platform, a Microsoft platform, which is available as a service in Microsoft Azure, but we can also deploy it on VMs. And since we still have some microservices on Service Fabric, we still need to maintain and manage this platform. You can see it like a Kubernetes-like platform, where you deploy. It's a platform you deploy microservices, and you decide the number of replicas, the resource, and so on. And then we have the last block is Kubernetes with Linux nodes. So it's here. The two other ones are Windows VMs, but here we are in Linux. And on Kubernetes, what do we host here? We have web apps, so already one of them, but the 3 other ones will at some time come here as well. Microservices, So we have already quite a lot of them, but some still need to be migrated from Service Fabric. What else do we have in Kubernetes? We have Redis. We use Redis for caching and for a graph database. So it has two purposes. And this is Redis cluster that we manage by ourselves. So it's all managed by Opinum. And lastly, we have Devops agent here on Kubernetes. These are actually Microsoft Azure Devops agent. The deployment of web apps services is made through Azure DevOps release pipelines, and we use this to automate deployments and releases. We will see that on the next slide. So this is all managed by Opinum. Of course, as we will soon see, we need you to provide us VMs, virtual machine, Windows here, and the Kubernetes cluster, as well as the networking that goes with it. The three other blocks, the external other blocks, must be provided and maintained by you, by the client. So I'll come back to external services later, but the two other ones are for enterprise services and managed service. So enterprise services are basic between code services that we need access to, like NFS storage for the disk and the file shares that we need for our application components, a Docker registry for the Docker images to deploy to Kubernetes, a DNS server, because we have, as you can see on the diagram, there are DNS entries to create to access the application from external, but even internally we need a DNS entries to be created for the modules to communicate with each other. Normally also an FTP server, it depends your use case. If you don't have data collection through FTP, this is not required, but often this is required because there are some FTP push to push the data to the system, and then on the same TP server for notification, notably for report sending, for user invitation, and so on. We need to be able to send emails. Managed services, it's mainly for services that we need, the database services. So there is one we manage ourselves, it's Redis. But there is another one which is there are four other ones that you need to provide to us and maintain it in a high availability mode. It's Cassandra for the time series that has tags, MongoDB, SQL Server, and RabbitMQ, which is for queues. External services, it's only if, because we have connectors to external services like Power BI, Blob Storage, we can export the data to these services for instance, for visualization or reporting. That's out of scope for this session. So to come back to this two set of architecture blocks, as I said, for data hub, the Opinum is in charge of setting up and maintaining Service Fabric and IaaS. For Kubernetes, we will set up all services within Kubernetes, like third-party tools like Redis, Istio, Prometheus, Grafana, Jaeger, and so on. However, we are not responsible for the cluster itself, so it needs to be provisioned and maintained, meaning nodes patching, Kubernetes upgrade. This has to be done by you. That we don't do. The same, for instance, we deploy IaaS and Service Fabric on Windows VMs. The patching of these VMs is also you are in charge of this. What we also maintain is the deployment, of course, and maintenance of our web apps and microservices. That we are in charge of this, and most of this actually is scripted and automated. As I said when we were reviewing the diagram, the other blocks, they must be managed, they must be set up and managed by you. This is the case for Cassandra, MongoDB, RabbitMQ, SQL Server. And this is also the case for enterprise services and possibly external services. There are some of these services, they could be managed by third-party providers. For instance, for Cassandra, there is DataStax, which is a provider. Of course, this is a paying service, but you can have a contract with them, and you pay a license. Of course, there is always a license to pay for Cassandra. But they can also maintain the service on your infrastructure, specific contracts, and they do everything regarding the maintenance. For MongoDB and RabbitMQ, if it's affordable by you, there are external providers like Atlas MongoDB or CloudMQP RabbitMQ that can be used. Of course, this is not anymore hosted in your infrastructure, but if it's affordable, these services can be hosted externally. A little bit more information about our main technologies and tools. So most of the modules are developed in .NET Core, and they are deployed on Kubernetes, Service Fabric, and IaaS. Cassandra database is used for time series. MongoDB, SQL Server, and Redis, they are used for MongoDB, SQL Server for metadata, and Redis is used for both cache and graph. So we have persistence with Redis. It's not only in memory. Some part of the cache is in memory only, but for graph, we need data persistence. And then we have RabbitMQ for queuing between the different components of the platform and also for incoming data. In terms of tooling, deployment tooling, we have other tools, but in terms of deployment tooling, as I said, we use Azure Devops, which is a CI/CD tool like GitLab or TeamCity or Circle CI. And to deploy on Kubernetes, we use Helm packaging, Helm charts, and on Service Fabric, there's a specific packaging mechanism that is available. In terms of scripting, we use PowerShell, Bash, and Python. And this is how it works with Azure DevOps. So as I said, we deploy an Azure DevOps agent, actually two, a Windows and a Linux one in Kubernetes. A Linux one only in Kubernetes. And from there, we deploy web apps, services in Kubernetes, in Service Fabric, and in IaaS. And this is a pull, so there is no access from internet here. Is the agent which will pull as orders from Azure DevOps in the Azure system. Right, now let's quickly review on supported on-premises models. So we support five models. The first one is private cloud, your own data center. So you have your own hardware, or you have a data center provider that you work with, and you can provision VMs, the managed services, Kubernetes cluster, and then, as we said, we can deploy our application there. Another mode is Microsoft Azure, OpenHome Manage. That means here it's not anymore. The difference with Microsoft Azure Client Manage is that in OpenHome Manage mode, it's us who set up network, virtual machine, Kubernetes cluster, enterprise, and manage services. We all do this. We have script to it, and this is what we do actually for our shared production instance. So there we can manage everything for you. But we can also do it in client managed mode, like when you are on in a data center, you provision the VMs, the Kubernetes, the managed service yourself in your Azure subscription, and we do deploy our stuff like if we were in a private cloud data center. And actually, we can do the same with Amazon Web Services and Google Cloud Platform. What will be supported in the future, probably somewhere next year, as the same Open Managed Mode for AWS and GCP, Google Cloud Platform, where we can set up everything for you. In terms of on-premises deployment requirements, what we need to have to be able to deploy on your own infrastructure are already almost covered, most of them. You need to provide us a bunch of Windows Server virtual machine, a Kubernetes cluster, a Cassandra cluster, MongoDB, service, RabbitMQ, SQL Server. Of course, we need all the network configuration that come with it, VLAN, routing, load balancing, and so on. We also need enterprise services, DNS storage, Docker registry, and so on, as I already explained. And if you have high availability requirements, of course, these services should be set up in HA cluster mode, which is required most of the time. And actually, I already mentioned that as well. If needed, appropriate for some of the services, you can use a provider that will do management for you, either in the cloud or even in your infrastructure, like DataStax for Cassandra. So what's currently ongoing is at Opinum regarding on-premises deployments. We are migrating all of our services and web apps to Kubernetes, and the completion target is 2021 Q1, approximately, but maybe a bit later, a bit sooner, but that's what we target. And we are also currently setting up an on-premises instance in a client's private cloud in a data center in France. Regarding once we have migrated all of our services and web apps to Kubernetes, the architecture diagram will look simpler. So we'll get this. You see, you have only one block now. We have no more Windows VMs. With IS Service Fabric, we have already only Kubernetes. And so the rest is the same. And that will be even easier to set up in your infrastructure. And we'll also move away from Devops agent, and we'll move to Kubernetes operators to deploy, so that we can deploy this way, where it's always in Kubernetes. And of course, there will be some link with external Docker registry, possibly, and maybe some external resources, but most of it will happen here in Kubernetes. What's next on the roadmap that we plan to work next once we have migrated to Kubernetes? All of this, we plan to migrate to Terraform for the provisioning of all resources. This is mainly for Open Managed Mode, where we set up ourselves Kubernetes, virtual machine, network, and so on. Currently, we have scripts, PowerShell, and PowerShell and Azure CLI scripts to provision these, but once we will move to AWS and GCP, we will migrate to Terraform so that we can provision infrastructure in these cloud providers similar, the same way between the cloud providers. And at the same time, we'll migrate to Kubernetes operators, as I mentioned on the previous slide. Once we have this, we will do the work to be able to support AWS and GCP in Open Managed Mode, where we can set up everything for you, network, virtual machine, Kubernetes cluster, enterprise services, managed services, and so on. And the last thing we plan to work on, there will be other ones, but for now, it's embedding, like we did with Redis, embedding these services within Kubernetes, MongoDB, RabbitMQ, and SQL Server. And that's it. I think I have covered everything I wanted to say. Thank you for watching this session. If you have any question, don't hesitate to contact us using the contact form on our website. We'll be happy to answer all questions you might have.